All right, let's talk about a very important component that we're going to use, and that's known as transformers. That's an N. All right, this side of the transformer, the left side of the transformer, is called the primary. This side of the transformer is called the secondary. What I happen to have here, the double lines in parallel, this designates that I have an iron core. And so the iron core transformer is the most common transformer that we use. And so typically what we're going to do is we're going to apply some kind of a voltage here. This will be V primary, and the voltage that we're going to have over here will be V secondary. Now the uses, common applications with this one, I don't want to put it there, so I'm going to put this over here. Number one, voltage step up and current step down. Another application would be number two, voltage step down and current step up. Number three would be what we call unity gain transformer. And what this means is neither voltage step up or down. So your transformer applications very commonly is going to be voltage step up, current step down, or voltage step down, current step up, or unity gain transformer. And the different applications of each of these are shown here. Voltage step down is the most common one, current step up. This is the most common one that we're going to encounter. Most common. And this is found everywhere in all of your electronic components. So from your TV, from your cell phone, cell charger, your laptop, your gaming devices, whatever they may be, anything that plugs into the wall that you are likely to use, you most likely will have a voltage step down transformer, current step up. There is a very specific application for this guy where you want to step up the voltage. So here, let me give you an example. I'll give you some numbers. Back to voltage step down. So here we may have 120 volts on the primary, and this might go to 12 volts on the secondary. So my V in is equal to 120 volts on the primary, and I might have a 12 volts on the secondary. This would be my V out. In a voltage step up transformer, I might have this. My V in might be 120 volts, but my V out might be 240 volts. Where would be a practical example of using a voltage step-up transformer? Why on earth would I want to step it from 120 volts to 240 volts?
A washing machine?
Dryer.
What dryer? We wouldn't
Tesla
do
car.
that. Tesla car. That's the default answer for everything. Yeah, we'll call it a Tesla car. No, no, no. A would be wrong, B would be wrong, and Tesla would definitely be wrong in this particular case. No, we would use this for our international laptop, let's say. International laptop. So let's say we have a friend visiting from England and they're using 240 volts in England. They have a 240 volt laptop. They can't plug it into our wall outlet because our wall outlet's only 120 volts. They need a voltage converter. Inside that voltage converter will be item number one, a voltage step-up transformer, which will take our 120 volts US and kick it up on the output to 240 volts so they can plug in their laptop. So that's one of the most common applications for all diplomats, anybody who works in an embassy, anybody who works in international business that travels to foreign countries, and foreigners come traveling to here, they have 240 volt devices. So they have to use a voltage step up transformer, okay? Whereas the rest of us, for the most part, what we're going to encounter is going to need a voltage step down for our devices. Where do we find a unity gain device? A unity gain transformer. This would be used in a testing benchtop. This is often used as a testing device on a benchtop, and it's for isolation purposes. So you will not likely encounter a unity gain transformer unless you're working in diagnostics, troubleshooting, things of that sort. All right, so these are the most common applications. Now, let me give you some transformer formulas. Very easy. Oh, let me give you an abbreviation. Transformer is also known as X-former. Okay, where the X is equal to trans. We also use this if X-former is a transformer, abbreviation for a transformer, then what is an existor? That would be an abbreviation for a transistor. Okay, very common to use the X for trans. All right, so transformer formulas. So X-former formulas. There's very few, and they're very easy. They are V1, VP over VS is equal to NP over NS is equal to IS over I primary. So here, V is voltage. N equals my number of turns. I equals current. P equals primary. S equals secondary. So there's your legend deciphering what each of those letters means. Then there's also another part of the formula where we have FP equals FS. So F stands for frequency. And then you have P primary equals P secondary. And I'll just use 3-letter abbreviations. And P stands for power. So in an ideal situation, the power of the primary is equal to the power of the secondary. Frequency of the primary is equal to frequency of the secondary. And we happen to have this set of ratios for transformers. Hopefully you can scribble this out real quick because I'm going to need to use another part of my screen here for drawing things out. I'll try to leave this in place for now. Let's just scoot this up here and give me just a little bit of white space here, all right? All right, so that being said, let me see if I can do this. I want tiny and I want black. I want this. Okay, let's see how we do. I have 120V, and that's RMS over this side. I will have transformer. I will have my iron core. I will have this. And my legend will call this N1. This will be N2, so number of turns in the primary, number of turns in the secondary, and this will be my V2. So if I say this, if N1 is equal to 30 and N2 is equal to 5, comma, 5. V2 equals question mark. So take a moment, scribble this out. You can transfer it more neatly into your notebook later, but scribble this guy out. You have one set of coils on this side with a tap and a tap, 120 VRMS. I'm specifying N1 on the top of the first coil, N2 on the top of the second coil, and V2 over here. What I'm asking you to decipher is, based on these formulas, what my V2 is going to be. It's a very easy application, but take a moment and copy this down. N1 is given as 30 turns, because N means number of turns, so I've got 30 turns, and N2 is 5. And I'm looking for V2. Now, the way you solve this is really quite simple. Let me show this to you. You will use the part formula that has the information you're given. Take a look at the formula here. So here's the formula right here. This is the big formula we're going to use. And what parts of this do we have, and what parts are we looking for? Do I have any aspect of current mentioned in this exercise here? Is there any current mentioned in here at all? None. So I'm going to forego using this last ratio. Do I have N values, N1 and N2? N1 and N2 are the same thing as NP and NS. I have Ns. Do I have voltages? I have voltages. So I'm going to use the first two ratios. So V primary over V secondary is equal to N primary over N secondary. That's the same as V1 over V2 is equal to N1 over N2. Why we use P versus S, we use 1 versus 2, it just depends on who the author of the problem is, but these ratios are the same. So when I'm referring to V primary, I am referring to V1. When I'm referring to V secondary, I'm referring to V2. When I'm referring to N primary, I am referring to N1. When I'm referring to N secondary, I'm referring to N2. Same difference. So what information, I'm going to use these ratios. Do I have information I can plug in? Yes, I do. I can go ahead and plug this in. How about my primary is 120V, and my secondary is VS, and my N primary is given as 30, and my N secondary is given as 5. Did I fill in red the numbers that were given to me in my schematic? And did I fill them in the appropriate place? VP is my primary voltage, in fact, 120V RMS. VS is what we're looking for. I don't have a number for that yet. N primary is the same as N1. Did I have that? 30. N secondary is the same as N2, and that's 5, so it's 30 over 5. I have one unknown in a pair of fractions. What do you recall? How do you recall solving an unknown in a pair of fractions? Question goes to Chisamaga. What do you recall doing? Solve. How? Solve how? How would I solve for VS? Do you remember?
I don't think so.
That's all right. That's okay. Not everybody does. Let's take a look. Abbas, do you remember?
Yeah, so you cross multiply, like you, okay, so draw an arrow from the 120V to the 5, and then so it becomes 120 times 5 is equal to 30 Vs, then you divide by, oh wait, am I going too fast?
Yes.
Oh,
I keep losing this. No, I don't want to do any type of installation. So I will cross multiply. That's the key. What am I cross multiplying is this. I have 120V over Vs is equal to 30 over 5. What I'm cross multiplying is this to this, this to this. So cross multiply will result in 120V times 5 is equal to Vs times 30. Does everybody see how to do the cross multiplication? Does this bring back memories of basic fractional reduction? So all we're doing is we're cross multiplying the 120 times the 5 is equal to Vs times 30. If I have this equality, I can do this cross multiplication. So let's go ahead and do this. What's 120 divided by times 5? Isn't that 600 over this side? Yes or no? Is equal to Vs times 30. Have I taken this from 4 expressions now down to 3 expressions? Now I have one more thing to do in order to isolate Vs. How do I move the times 30 from this side to go to the other side of the equation? What is the maneuver that I'm going to do here? Question goes to Kirsten. Jess, what would I do?
Multiply both sides by 30, or sorry, divide both sides by 30.
Precisely. We use the opposite math function. If we're trying to get rid of this times 30 on this side, you want to divide by 30 on both sides. So this will cancel out your 30s, leaving you with Vs over here. And what is 600 divided by 30? Isn't that going to give us 20? Dana? Concur? Everybody? Do we get 20?
yeah.
So
Yes.
20. So Vs is equal to 20. Vs is equal to 20 volts. All right, 20 volts RMS. Are we good with this application? How do we do this again? We look back at the original transformer formulas. And again, you should have this in your notes. Vp over Vs equals Np over Ns equals Is over I primary. And that would be the same as V1 over V2 equals N1 over N2. And this is, in fact, equal to I2 over I1. All right. All right. Let's give you another one to play with. Another one to play with would be here. And let's say this is 216V RMS. And let's say this guy is 15 and this is 2. And I'm looking for V2. So go ahead and set up the structure of your solution. The structure of your solution, since no current is mentioned here, we can go ahead and use the first two ratios. V1 over V2 equals N2 over N1. Fill this in with the numbers. So let's see, let me have, Dana, could you help me fill in the numbers? What's my V1? Dana? Harpreet, what's my V1?
It's a 216 volt.
What's my V2?
That's what we're gonna look for.
That's what we're looking for. What's my N1? Oh, I wrote this. My dyslexia. I'm sorry. I apologize. I got dyslexic on us. Do that. Okay. V1 over V2 equals N1 over N2. I spoke it correctly. I did not write it correctly. Sometimes it creeps in. Sorry. All right. So what's my N1?
15.
would be 15. What's my N2?
2.
2. Okay. Is everybody satisfied with how we fill this in? 216 volts over V2 and N1 over N2 is 15 over 2. That being said, now what we're going to do is our cross multiply there and there. So the next equation would be written how? Tony, how would I write the next equation? What equals what? Tony, microphone.
Oh, sorry. 216 times 2
216 times 2
equal 15
equals
times BS.
15 times, watch out,
Oh, V2.
times V2. Perfect. So far that would, how many people agree with this next step in red? So far so good? All right, so now we're going to do one more step, and that step, give that to us please, Erica. What would we do now?
Divide both sides by 15.
Okay, divide sides by 15. Divide both sides by 15. And so we should have, if all goes well, we should have 432 over 15 is equal to V2. Is that correct? And so that would calculate to be what value question goes to Carlos?
28.8.
432 divided by, what's that?
28.8 V RMS.
How many people agree with 28.8 V RMS? And that would be 28.8 V RMS, and that's equal to V2. Very good. All right. So far, are we okay with transformers? So we start off with 216 volts on this side, and on the other side, we end up with 28.8 VRMS. So input was 216, output was 28.8. Which one of the three applications would this be? Francisco, is this application number one, where we have look at the three applications again, where we have voltage step up, current step down, or is this, sorry, I mean to be
step down?
doing this too fast. This would be a voltage step down, current step up transformer, yes? So it would be a second application, yes?
Yeah.
You're right, yeah, voltage step down. We've taken a higher voltage and brought it down to a smaller, safer voltage, all right? So far, so good? All right, how about, and that's really a good start in transformers, all right? We'll have some, I'll do one more, just to spin things up a little bit. And I'm going to say my V2 is equal to 17V. And I'm going to have 5. And over here, I'm going to have 12. And I'm looking for V1 equals question mark. So doodle this out. Transformer symbol. V2 is going to be given to 17 volts RMS. It could be peak, but I'll just use RMS. This is my N1. N1 is 5. My N2 is 12. And I'm looking for V1. So I'm looking for how to get started with this exercise. What's the first step that we should do? First step is to do what? Luis, what should be my first step?
Set up your formulas.
Okay, we want to set up formulas, so I'm going to write that out. First step is set up formulas. Set up my formulas, all right? And so in doing that, Ephraim, can you give me formulas that I'm going to be using for this exercise? Ephraim.
You want the formula or the numbers?
Well, formulas.
Formula. So it'll be V1 over V2.
V1 over V2.
Equals N1 over N2.
N1 over N2. Very good. Now I'm going to be looking for the numbers. So the numbers will come from, let's take a look here. Chisamaga, what numbers do I fill in here?
So you would have V1 over 17 volts
I have
equals
V1 over 17 volts. That's equal to
5 over 12.
5 over 12. How many people agree with that formula in green? We good with that? Okay, so far so good. What would be my next step that we would do here? Question goes to Ryan. What would be our next step?
The next step would be to cross multiply 17 with 5 and 12 with V1.
Okay, so second step is cross multiply. And so when I cross multiply like this, my equation will be 17 volts times 5 is going to be equal to V1 times 12. So far, so good. All right, so that's a good second step. And now let's go ahead and continue. The next question goes to Harpreet. What would we do next?
So we're going to multiply 17 by 5 and divide by 12.
Okay, so 17 times 5. So what does 17 times 5 give you on this side, my friend?
85.
Harpreet? Okay, so we have 85 on this side. Very good. And that's equal to V1 times 12. So good. So far, so good up to now. What would we do now? Next question goes to Anna.
You would divide both sides by 12.
Okay, divide this by 12 and divide this by 12. And what would be the result of my math on the right-hand side, Anna?
7.08.
Oh, okay, I would end up with a V1. And on this side, 85 divided by 12 worked out to be, you said 7.08?
Yeah.
7.08 volts, RMS. So are we in agreement on the left-hand side, we would have 7.08 volts, and that is in fact equal to V1. So I'm going to take this and now write it in here, 7.08 volts. So my input was 7.08, my output on this side, 17 volts. Which of the three applications is this? The first, second, or third? Question goes to Gregory. Is this voltage step down, voltage step up, or same?
Step up.
Voltage step up. Yeah, we went from a measly 7.08 over here up to 17. So this is an example of a voltage step up transformer. So let's just go ahead. Voltage step up transformer. Are we good with this so far? Okay. Okay. So where this is significant, my friends, is this. Let me take us off the share for a moment. All right, can everybody see my big picture of the power supply? Big picture of the power supply, good. So what we happen to have right here is a transformer. This is A would be the primary voltage, B would be the secondary voltage. We have an iron core, and then the transformer is given with a symbol marked T for transformer. We have a fuse, a switch, and a wall plug. So what happens here at your wall outlet is you have 120 volts RMS, which is a big peak voltage of 169.71 volt peak. That's at A. At B, because this is going to be a voltage step down transformer, we will have a smaller peak voltage as an output at B. So the job of the transformer is the very front part of your power supply, and this is the same way your wall wart is built, same way your the power supply on your breadboards are built. You have a wall wart, that's this part of it. Inside the wall wart also happens to be a diode, and there's a capacitor, and so the diode changes the AC to DC. which is what we have here between B and C. This is AC on this side. And then the output at C, which is this side of the diode, we happen to have DC. This is a pulse, but there's only one polarity. So it's not straight line DC, it's pulsating DC. And that's accomplished at point C. If I introduce a capacitor, the job of the capacitor is to do what? It's called a filter capacitor, and it smooths out the DC pulsations, and I have less bumpy of a waveform. Then I'm going to shoot the signal from point D into an IC voltage regulator, and the IC voltage regulator, the output of that, gives me in this picture here, E, straight line DC. And then it goes into a protection circuit, and then it goes to your load. So this is the big picture of the power supply, and the most critical part that we're focusing our energies on right now is T1. What is happening around a transformer? All right, all right. Okay, enough about transformers. You'll see some exercises on calculating values on transformers. There also happens to be other types of transformers, which we'll get into in later courses, like center tap transformers and sophisticated DC, AC to DC conversion other than a single diode. But this is the basis and the beginning of it all is the big picture of the power supply.